All right, welcome everybody. This is our first video lesson for computer science, and today we just want to do some review with decimal and binary before we get into hexadecimal. All right, so decimal is our regular counting system, and another name for decimals it says here is base 10, and this is because there's 10 possible states for each place value. Okay, so we have the numbers from 0 to 9 in each place value. Also, each value increases in powers of a base of 10. So for example, when we have a number like 346, what we're really saying is we have 3 hundreds, 4 tens, and 6 ones. All right, so if I was to draw that out here, so first we'll put our place values. Okay, and then the first one is the ones place. This is the tens, and this is the hundreds. Okay, and then now with the number like 346, what we're saying is we have 3 hundreds, 4 tens, and 6 ones, just like that. All right, so this is going to be important because now when we get to binary, all right, in binary, we call this base 2 because there's only two options, 0 and 1. Okay, this is, aside from the fact this is also where the name or the term bits comes from for binary digits. Okay, and in here, each place value increases in powers of the base of 2. So what that means is when we start from the right, this is a ones column, 2 column, 4 column, 8 column. So to begin with, we can start with 4, but if you were to go further to the left, then we have 16, 32, and I'll stop there. Actually, let's do one more, 64. So these are all powers of the base of 2. Okay, so right now we're not going to be using all of these, so I'm going to put some zeros in a second. But for example, when we have this number 1, 0, 1, 1, what we're saying is we have 1, 1, we have 1, 2, 0, 4s, and 1, 8. And in these ones right now, for the purpose of this, I'll just erase them. Okay, so as this shows here, now that we know that we have 1, 8, 0, 4s, 1, 2, and 1, 1, we can add up these numbers, and what we get is number 11. Also notice they have this small little 10 here that's called subscript, and that you can use as well to distinguish that this is 11 in base 10, whereas this is 1011 in base 2. Great. Okay, so with that knowledge, now we can keep moving on. So we already saw how to convert binary to decimal, right? We see which place values have a 1, then we add those up, and we get our decimal number. To go from decimal to binary, It's a little bit more tricky, but not too much. So let me show you here. If we have the number 19, sorry, one sec. Let me close my email. Okay, so here we have the number 19, and as it says here, just keep subtracting the largest possible place value. So what I would do is I would already start setting up some of these place values. So let me write 1, 2, 4, 8, and from here 16. And then before we go any further, we're going to ask ourselves if we can go to a bigger number. Next number will be 32. That's too big, so we stop here at 16. All right. Now from here, and I guess they skipped a lot of steps with the math here, but now what you're doing is you're subtracting by the largest available value. So this is kind of like remainder division. Okay, so we have a number 19. We know that 16 can subtract from 19. So we'll put a 1 here. And if it helps, you can write this too in the margins. Let's do 19 minus 16. Try to form these letters with my mouse. Okay, that's 3. So we know 8 is too big, so that's 0. 4 is too big, so there's a 0 there. 2 can subtract from 3, so we do 3 minus 2, which is 1. And we know 1 can subtract from 1, so there's another 1. Okay, so I kind of covered it up here, so I'll rewrite the binary number. 1, 0. Okay, so 19 in base 10 is equal to 10011 in base 2. Once again, apologies for some of these numbers in the mouse here, but hope you guys are catching along. Remember too, if you're watching this in class, feel free to pause and rewind at any point, and also ask me any questions that you have about the videos as well. All right, so here's a chart that you can refer to, and now we get into addition. All right, so you can convert numbers, but I'm also going to show you a different way, right? You don't have to convert it like this. I'll show you a different way that you can add. So I would say on the test, try the way I'm about to show you first, and then you can always check your answers by converting the numbers over, then adding them. Okay, but yeah, at the end of the day, as long as you're showing your work and you're getting the right answers, that's all that counts. Okay, so let's add these up. All right, so we know that each column only has two options, 0 and 1. So when we add this, we have 1 plus 1, which is 2, which means that we have a 0 here at the bottom, and we carry a 1. 1 plus 1 again is 2. 2 plus 1 is 3. So we have a 1 here, carry another 1. 1, 0 plus 1 is 1, and 1 plus 0 is 1. So we're left with 1, 1, 1, 0. Okay, let's add this side here. So this is 0, and that'll give us 30. All right, and then now if you want to check the values, so I'm just going to rewrite this number here so it's a little bit bigger and easier to see. So we have 4 ones, 1, 1, 1, 1, 0. Now we can put the place values. Okay, now that we have the place values, we can convert this binary number into a decimal number just to double check. So we have 16 plus 8, that gives us 24. 24 plus 4 gives us 28, and then 28 plus 2 gives us 30, which we see we got the right answer. So that's 30 base 10. All right. Subtracting. Now, subtracting is a little bit trickier and I'll probably pull up one of the ones from the worksheet as well that we can work through. But let's try this one out here first. All right, so here we need to borrow, right? We can't do 0 minus 1. We need to borrow 1. So let's borrow this 1. That becomes 0. And when we carry the 1 over, it doesn't become 1, it becomes 1, 0, which in binary is 2. Okay, so if you need to pause, like I said, if you need to pause at this point to review that, go for it. But when we borrow that 1, this doesn't become 1, it becomes 1, 0. Okay, so now let's proceed. 1, 0 minus 1 is 1. 0 minus 0 is 0. Answer, 1 sec. Mouse is acting up. That's 0. 1 minus 1 is 0 again. And then over here, we need to borrow another 1. That becomes 1, 0. That becomes 1, 0, and 1, 0 minus 1 is 1. Okay, and then just by looking at this, we can see this is 1, 2, 4, and 8. So this is 9. Right, this is 8. This is 1. That's 8. This is 1. And if we subtract from the right hand side, it's 1, 12. 12 minus 3 is 9. So we see we got the same answer. All right, so let me see if I can pull up any questions. I know this video has gone on a bit long already, but really wanted to review, make sure that we got some of these fundamentals down before going to hexadecimal. All right, so give me 1 second, guys.